Hey everybody, Professor Miller here with a problem that tends to confuse people over the years. So let me help you with it a little bit. The basic thing to understand here is there's a whole series of different problems that we could form like this, and they're all going to involve coupon rates, yields to maturity, time to expiration, and price, all the things that the CYPF will tell us. So if you're good at pricing bonds, these type of problems are no problem at all. So in this particular case, we have two bonds, both with a 6.8% coupon rate. They're priced at par. What's that tell us about the yield to maturity? CYPF, coupon rate equals yield to maturity means price is equal to par. So the yield to maturity on both of these bonds is also 6.8%. Bond A, 9 years to maturity. Bond B, 15 years to maturity. So we start off with both yields to maturity are 6.8%. And the question says now, hey, suppose the interest rate rises by 1.2%. When you see interest rates, that does not mean the coupon rate, that means the yield to maturity. So what's the percentage change in the price of bond A and bond B? So what you have to do is compute the price today. We know is price A is, or excuse me, both bonds are priced at par. And so basically, bond A has a price of $1,000. So if yield to maturity by 1.2% to 8%, then we just have to calculate the new price of the bond. And so this is the old price of bond A. The new price under the new yield to maturity is, well, you'll have to just work it out yourself, but we have 18 coupon payments, a coupon payment of $34. Coupon payment comes from the 6.8 times 1,000, gives us $34. So the new price of the bond A, when you run it through your bond calculating formula, you should see that the bond price is 924. I wish I'd remembered this. I believe it's 924.04 is what I believe. Okay, so check that number out. Make sure that that's what you get when you increase the yield to maturity to 8%. And I have a video posted for you how to use your TIBA2 Plus to calculate bond prices. Here's your chance to use it. Okay, so now it says, what's the percentage change? Well, we know that's the new minus the old divided by the old, which is 924.04 minus 1,000 divided by 1,000, and that is equal to minus 0.0760, or minus 7.6%. As a check figure, the new price for bond B would be 896.25 if I did it right, and I'm hopeful I did, because I will hear from you if I didn't. All right, so what do we see here? Yield to maturity goes up. What happens to the price? They both fall. Oh, and this bond here, the new percentage change for bond B is, well, the actual change is minus 0.1038 or 10.38%. If then part B of the question says, oh, wait, we didn't mean interest rates went up, they went down. And we know by one of Malkiel's theorems that, hey, interest rates, i.e. yield to maturity and bond prices, are inversely related. So the yield goes up, price of the bond falls. Yield goes down, price of the bond increases. So try this as an experiment yourself, or you'll be asked this, but let me give you a couple check figures here. So if the interest rates fall by 1.2%, now the yield to maturity is 5.6. It fell from 6.8 to 1 by 1.2 down to 5.6. Bond A's price will go up because the yield to maturity fell, bond price goes up, and that new price is 1,083.93. Bond B will be I think it's 1120.70. You better check me on that. And then you can calculate the percentage changes using our percentage change formula up here. Okay. So again, this problem just calls for you thinking it out about what's going on here. Calculate the bond prices today. We gave you a break here on this problem because we're pricing them at par. You don't have to start off by pricing them at par, but that was just one possible explanation. So good luck with that, and